Thank you for coming to my talk. I'll be talking about some cultural factors that are relevant to math knowledge, in particular commutativity. Sorry, I'm just trying to figure out how the clicker works. Oh, okay. Where should I point it to? For Thank you. So to define commutativity specifically, we mean the commutative property of addition for the natural numbers. So this is for all a and b, assuming a and b are natural numbers. A plus b equals b plus a. In other words, the order in which you compute the sum is irrelevant to the final answer. So why do we study commutativity? First of all, it's a simple property that's perhaps more amenable to a clearer study and interpretation. Also, it might be representative of how we understand other arithmetic properties like the associative property, for example. Commutativity can also facilitate arithmetic computation. When children are first learning how to add, they have kind of different stages of how they do this. For instance, if they're presented with the sum 2 plus 5, some children will count on from the first addend. So, for instance, they'll have in mind 2, and then they'll add 5 to that one at a time. So they'll say 2, 3, 4, 5, 6, 7. But if the children had merely kind of flipped the addends, they would have to do fewer iterations in adding the second addend. They would just have to do 5, 6, 7. So this is kind of the more sophisticated count on from larger strategy that is possible through commutativity knowledge. Thirdly, in mathematics, the property of commutativity can be used to derive further mathematical properties and structures. So in certain versions of the Peano axioms, commutativity is assumed or axiomatic, and from there mathematicians can derive more complex things like constructing the natural numbers. So one question is, how do we learn commutativity? In particular, we can ask, do we need social cultural supports to learn it, or can we learn it autonomously? And I'll go a little bit more into what that means. So under one hypothesis, commutativity is learned through strong cultural social supports. So for instance, social input relevant to math, like formal schooling, specific language-based skills, like knowing the meanings of the number words and exact arithmetic, and also occupational experience. So for instance, experience selling goods in the marketplace. Alternatively, commutativity might be deduced autonomously, more independently through individual experience, observing quantities and their combinations in the world. So some former research that could support the cultural support is necessary for commutativity knowledge hypothesis has been done in WEIRD children, so the acronym standing for Western Educated Industrialized Rich Democratic populations. So work has shown that understanding of commutativity evolves. So initially, children have an abstract understanding of commutativity on unspecified quantities around 4 years old, and then they acquire a more complete understanding by around 3rd grade, where they can implement this principle to problems, but also kind of explicitly state the property when asked about it. Alternatively, cultural support may not be necessary for commutativity knowledge, and this possibility is supported by some work on the Dula, which is a population that is typically unschooled, or at least at the time of this publication. So they studied Dula adults on a battery of several math tasks, and they found that they did succeed on symbolic additive commutativity. However, an issue with this study is that each participant only completed one trial of commutativity because, it was within a larger battery of math tasks. And also, all these participants had uniformly high market experience, so they were all exclusively cloth merchants and tailors. So you could say that they have this strong cultural support of market experience, so it can't really address, the main question. So in order to address this, we recruited members of the Chimane, which is a farmer-forager population who reside in the Bolivian Amazon. They live spread across different villages alongside the river, each with their own separate schools, which can vary in, the material they teach. The villages vary in their proximity to towns, to market towns, so there are varying levels of market integration for inhabitants of each different village. So we recruited 45 Chimane adults, and we specifically looked for adults with low levels of formal schooling, and we went to 9 different villages. So for our methods, we did a survey of different cultural supports, and we also administered 2 different commutativity tasks. So for the survey of cultural supports, first we determined their number knowledge using a classical number knowledge task, the give-end task. You can ask for more details in the questions if you want. We also administered some addition problems. We also determined the number of years of formal schooling they had. We also determined the time it takes to travel from their village to the nearest market, and we also asked them for their age. And age was used as a proxy for experience with quantities in the world, for time to experience those quantities. So for the first commutativity task, we did a symbolic commutativity task that here is being demonstrated by our translator. And in this task, we had index cards with 2 sums written on them. So maybe it's a little more clear here. Some of the sums were commuted, some of them were not commuted. They had varying answers of same or different. But here's an example of a commuted trial. We would say 12 plus 14, 14 plus 12. Do these sums result in a different answer, the same answer, or is it not possible to know? And we also presented these problems quickly so as to prevent outright computation and kind of get more of a strategy to answer these questions, such as commutativity knowledge, which they could use to answer them quickly. Next, we administered a word problem commutativity task. Our intention was to have a task that's kind of less abstract and more grounded, perhaps a little bit more culturally appropriate or relevant. And we gave participants a story that there are 2 men, each of them with a certain quantity of pebbles in both hands. And in addition to the numerals, we also had dot clouds below each numeral representing the specific cardinality depicted there. So an example of a word problem trial would be, Juan has 19 pebbles in one hand and 17 pebbles in the other hand. Pedro has 17 pebbles in one hand and 19 pebbles in the other hand. Who has more? Does Juan have more? Does Pedro have more? Do they have the same amount, or is it not possible to know? Okay, so for our results, the results will all be in the same kind of format, where each individual dot represents a participant. In red, you see their performance on the symbolic commutativity tasks, and in green, the word problem tasks. And on the y-axis, you'll always see commutativity accuracy, and on the x-axis, it's subsequently more advanced levels of the particular cultural predictor we're looking at. So in this case, we're looking at knower level. So with increasing number knowledge, they fare better at commutativity. But more interestingly is the fact that at the low knower levels, no participant really succeeds on the commutativity task. Similarly, we see a similar trend with arithmetic accuracy. As it increases, people perform better on commutativity, but at lower levels, not that many people succeed on commutativity. Then we have the predictor of years of education, years of formal education, I should say. And again, we see the same increasing pattern, and people with 0, 1, 2 years of formal schooling typically do not succeed on commutativity. Here we can also see participants perform better on the word problems than on the symbolic problems. And here we see actually the opposite trend with the predictor of time to market. So the further you are from the market, the worse you perform at commutativity, but ultimately this predictor was not actually reliable in our statistical analyses. So kind of, as an interim summary, we can see that cultural supports really make a difference in knowing commutativity, but can time to experience quantities in the world make a difference? So here we see that it appears not to make a difference, and in fact, the older you are, the worse you perform on commutativity. And we think this is probably because the older participants were of school age back when schooling wasn't as formally implemented in the region. So that's why they perform worse on commutativity. So this sort of kind of summarizes the significant predictors in predicting commutativity accuracy. So we see that education was reliably predictive, as was arithmetic accuracy, as was number knowledge, but time to market didn't end up being predictive. And age, as I explained before, was not predictive, in fact, was kind of negatively predictive, I guess. And overall, people are also more accurate on the word problems than on the symbolic problems. So for some conclusions, we see that cultural support, as opposed to passive individual experience, is important for commutativity knowledge. People's mental concept of arithmetic is not automatically commutative, contrary to in the piano axioms, for example. And this sort of makes sense because in the real world, order often matters. So not everything is combining, two piles of pebbles. Say you put a bunch of fragile objects on the floor first and then added rocks on top, that would definitely make a difference to the outcome. So sometimes order matters, sometimes it doesn't in the real world. So this kind of begs the question, how is commutativity acquired? Some people postulate that maybe repeated exposure to addition problems makes you realize that the sum is, the order of the addends is irrelevant in computing the sum. And lastly, I wanted to make the point that a limitation of our research is that even though we made the attempt with the word problem tasks to make it a little more concrete, still that task we used relied on images, and even the images of dot clouds, it's not really tangible or concrete. So in order to remedy this, for our upcoming trip, we're going to use concrete quantities using actual physical tokens. And perhaps the participants will be able to succeed in those cases, irrespective of cultural support. I'm not sure, we'll see. But yeah, thanks so much for coming, and thanks to my advisor, Steve Piantadosi, and to my lab, the Kalala lab at UC Berkeley.